Aloha kakahiaka, everybody. That is like good morning in Hawaiian. Aloha is like hello. Kakahiaka is what you would say in early morning. It is not early morning right now, and I don't speak Hawaiian, so I don't really know what we'd say right now. But maybe you're watching this video super early. Okay, so here we go. Yesterday, we ended with multiplicity and repeated zeros. Today, much like the games, or the game horseshoes and the not game hand grenades, close. If you're close to the picture, I'm good with it. Doesn't have to be perfect. We're going to be sketching some polynomials. Now, here's the cool thing about it. You guys all love graphing, and I know you do, and everybody always says, Mr. Holloway, I'd rather not sketch. I'd rather just make a table with like 70 points and actually take the time to plot 70 points and draw the nice curve through them. I get it. Everybody wants to do that, but we're going to try to make it a little faster. Okay, we're going to do our first one together, and I don't really have anything to say other than example. We're going to put all the pieces that we saw yesterday together right now. So our example, we're just going to sketch. And we're going to sketch together f of x, and I'll make that a, I'm sorry. So I'm going to make you guys do it as well. We're going to sketch f of x is equal to x cubed minus 2x squared. Okay. Full disclosure, I have no idea what this graph looks like. Not even a little bit. I have a basic idea, at least to begin with, but I don't know for sure. Does anybody have a solid graph of this in your head right now? Good. I don't want you to. I don't want you to get it on your calculator. I want to see that we can make sense of it, at least good enough sense of it, to be able to knock this out. So here we go. If I want to start, can you guys tell me, I would write this a different way normally, but what happens to this function as x approaches infinity? And I'm going to write another one that says as x approaches negative infinity. And how on earth would we even check that? No idea what one might think to be able to get through a problem like this. Not a clue. I was dancing. I didn't notice that. Now, I feel the rhythm, but I also was trying to point you to something very specific.
End behavior.
There's some end behavior, right? Yeah. What's the degree of this, the biggest power of x?
3.
Is that an even number or an odd number?
Odd.
Okay. What's an easier odd number to think about than x cubed?
1.
X to the 1. It's this thing right now, okay? Is it positive or negative leading coefficient?
Positive.
So I don't care what goes on in the middle, but I know that x to the 1, if it's positive, it looks like this from your perspective. As I go to negative infinity, over here, what happens to a function? So I know it goes downward forever. So the formal statement would be as x goes to negative infinity, f of x approaches negative infinity. And what about as I go really far to the right? I'm backward. Here we go. Was I backward there? No, I'm okay here. What about as we go really far to the right? F of x does what? Good. Okay, here's the deal. I commented yesterday that this is the real formal language. Do we have a shorter way you could write this? This is formal. How are we going to write it?
Parallel line.
So kind of parallel down to the left, up to the right. I am A-okay with this. On a test, on your homework, this is good. On the AP test, no. Use this one. Okay. And maybe we'll try to use this one more than we have in the past. I know my graph ends like that. Now, don't sketch it yet, but I just want to show you where we're at without any numbers. I think I have arguably half of this graph done. I know it ends like this. Okay, you don't have to draw this yet. I would wait until we do it. But what I don't know is what happens in the middle. Now, it could curve up, and it could have a 0 that repeated thrice, and then just curve up. It could do that. I've seen cubes do that. Or it could be crazier and go whoop, and then come back up. It's one of those two. I don't know how high or low, but let's see if we can get something else. Are there any points in here that you're sure I might want to put on a graph?
2.
Why 2? So let me rephrase that question. Instead of saying why 2, how would I determine the points that might be placed along the x-axis? I'm looking for the somethings.
The factors.
The factors. Give me another word that I might ask for. The x-intercepts. Give me another word. The roots, the zeros, the solutions, whatever word you want. In this case, I would call them the x-intercepts because I'm on a graph. But can we find them? Well, okay. So I want to now find the roots, the zeros, the x-intercepts, whatever you want to call them. I'm going to just make sure that right here, I'll highlight it. This is EB, which is short for what? The end behavior. I'm going to switch colors here. We need the end behavior. We got it. Do you want to call them roots, factors, zeros? What's your thought? Zeros. Okay. The last time I wrote it, I'm pretty sure it had ES, so we'll go it this way. Cool. I need your help, though, because here I am, and I'm kind of embarrassed, but I don't remember how to factor. The good news is I got a class of a bunch of people that do.
Take x squared out of it.
I can take out the greatest common factor. It's an x squared in this case. X squared, what did it leave behind?
X minus 2.
Okay, from this, can we find the zeros?
Yeah.
I'm going to say, therefore, x equals, now I'm going to write it differently than you might. What is the first zero?
0. And then 0 again because it's x squared.
0 and 0
And then 2.
and 2. Okay, now if you don't want to write it twice because you hate the way it looks, I'm cool with that. The alternative is you can just simply write just the two of them, x equals 0 and 2. In either situation, I'm going to make a... that looks like a face, but not intentional. All right, here's what I want to notice. It touched twice. It means I do what?
Bounce.
Bounce. And I am going to try to embrace that bounce rather than touch and turn because it's less writing. What does it do here?
Cross.
Cross. So check it out. I haven't even picked a scale yet. We're about to have to pick a scale. I know that I have a root at 0, and it's going to cross, and I have another root at 2, which, I don't know, I'm going to make those ticks of 1. So here's my 2. Now, notice, I didn't put any thought into where I put these, and I wouldn't have graphed them yet. I know that that's what's going on in my head. I'm going to make it look a little bit nicer for our actual graph. Okay. For just the purpose of getting a sketch, do you think I have enough to sketch it yet?
Yes.
I think so. Check it out. I'm going to try to do it in blue, and we're going to see. We'll check it against Desmos, and we'll see. Is that purple?
Yes.
That's not purple.
Yes, it is.
What?
That's purple.
That's purple.
That's indigo.
That's
It's
purple.
What?
That is not indigo, Karina.
It's between blue and purple.
No,
It's
that's a
indigo.
purple, Karina.
Yeah, that's indigo. That's
That's a
indigo.
purple.
All right. When you guys do homework, I'm going to take a picture of it and ask my phone what color this is, and I'm just going to Google Lens it to see what it says. You guys see purple? Okay, hold on here. It does look purple on that.
Karina, it's purple.
Indigo.
I'm confused.
Oh, that looks like a navy blue.
All right, maybe I'm a lot less colorblind than I thought, and it's just a difference in how it presents. Okay,
Blue enough.
look at that change in perspective. All right, anyway, we're going to use whatever color that is to graph this. Now, I know that it goes down forever. What I don't know exactly is whether it kind of mellows out and does something like this, which is possible. That does go down forever. But if I don't want to have to be super fancy, maybe I won't do that. I know it goes down forever over here, and I'm just moving my point closer. And I know it goes up forever over here. That's what we had. It's just a little bit more to scale. When I get close to this 0, what's going to happen when x equals 0? Does it cross it or touch and turn? Okay, so it touches and turns. Now, here's the other part. We don't know exactly how it turns. Is it possible that it could do something like this?
Yeah.
It could do that. Alternatively, though, is it possible that it's crazy and it does something like this? Both of them are okay, but if all we want is a general shape or a sketch, do they both say the same thing? Yeah. I don't know exactly what it looks like. Since it's just a sketch, I'm just going to include it. What happens at this root? Okay. Notice, real quick, did I take any time to get nice values?
No.
Nope. The only two numbers that I even bothered to put on here was a scale on the x-axis to make sure that I could identify these. If I wanted a little bit better picture, are there any convenient points that if I wanted to just plot a couple of them to get a better picture, we could? Okay. I want to be clear. For like most of the stuff, this is sketch is good enough. If we want it a little bit nicer, I'm going to do it in this lovely red crimson color. What values of x might you pick to make a couple easy points? At 1. What's 1 cubed?
1.
Minus 2? So at 1 it was at -1, which I promise I did not think this out. It's about there. Any other values? -1 maybe? What's -1 cubed? Minus 2 is -3. So at -1, it would have been at -3. 1, 2, 3. I promise I did not do this before. This is just working out perfectly. Okay. The more points we get, are we going to get a better graph?
Yes.
Now, with that said, I just want to see what the actual graph looks like. Because maybe we're close, and I don't know what it does in here. If we wanted to pick 1.5, we could. But let's just check. X cubed minus 2x squared. All right. Desmos. X cubed minus 2x squared. Huh.
It was like raining horizontally earlier, and now it looks sunny. Like literally 10 minutes ago.
Yep, I have.
Like the wind is blowing it so much.
Okay, check it.
There's still wind.
I'm pretty proud of this. Here's Desmos' graph.
So much.
It's pretty close. Now, is this easier than doing the points that everybody's always begging for? Is it super hard to do this in general? The picture's good enough. Now, the picture won't always be this close. That was like awesome that it worked out that close. It's okay if it's not. As long as you have the same key characteristics, the roots and the end behavior, you're going to get a good enough idea of what's going on. Okay, I want you guys to try one. So here we go. Bravo. Ooh, let's get real crazy. I want you guys to graph for me g of x this time, and you're just sketching, not graphing, I'm sorry, is negative x to the fourth plus 3x cubed. You are going to give me a sketch. The only two things I really need are the end behavior and the roots. Everything else, if you want to eyeball it or just think it out, I'm good with. I'm going to give you guys a couple minutes, double check my attendance because I get like 5 emails a day from the office telling me to do that. Cool. Once we have this, it's just a matter of how specific do you want your graph to be. I know I need to see 0 and 3. I'm always going to try to pick at least, I want to see the axis on pretty much every graph that I'll ever do. So I'll do it here. I know it's going to go downward, so I don't know how high, but maybe I don't need a whole lot of negative x values. I haven't picked a scale yet. Now, on that last problem, we needed the x scale sometime, right? I need to be able to show 0 and 3. Any objection if it's 1, 2, and 3? I already have hash marks on my screen. Can I use that as 1, 2, and 3? Okay. And then what I know so far is there's a root here, and there's a root here, and it crosses on both of them. Now, when I really draw it, I don't truly start down here and then connect it. I just look at this and go, well, I know it goes down. Is it ever going to come back here? If it were going to do this, what else would we have found? We would have found another root, but there aren't anymore. It's just these. So I know it never comes back up. I know that this thing's going to go down forever somehow, and I don't know exactly how, but there it is. Over here, I know it's going to go down forever again, and all we have to figure out is the middle. My guess is you guys probably have this picture. Theoretically connected, but that picture roughly. It's good enough. Now, are there easy x values that I could plug in to maybe get a little better picture? If I wanted it. And you don't. If you give me that first graph, it's completely fine. But if it's quick and easy, we should just do the next one. Give me another easy value to plug in between these. 1. And I'm not even going to make a table. What's 1 to the 4th power? 1. Times a negative. So -1 plus, what's 3 times 1? 1. So -1 plus 3, what value do we get? 2. Okay, so I'm just going to go up to where 2 is on my graph, and I'll just use 1 tick here since I already have it. And I just found that the point 1, 2 is also on this graph. It still agrees with your parabola. Is there another easy point that we could plug in? 2 to the 4th is 16, so we're at -16 plus 24. That's an 8. Here's where I'm just willing to guess no. 3, 4, 5, 6, 7, 8. Nobody probably has their graph doing this. It's okay if it doesn't. I think it does. Like, I know it does. We just verified that it does. Can I connect these and make a curve? Now, I don't know exactly what it'll be, but something like this. Okay. It's wonky. Like, that's okay. Graph looks funny. Do you think we're close? Let's check. -x to the 4th plus 3x cubed. -x to the 4th plus 3x cubed. Negative, thank you. I better make it y. Are we close? It's not perfect, but it's close. If I'd used -1 to get one more point over here and saw that it was here, would my picture be better still? With just 3 points added, I would have a really good graph of this. Okay, do you think that this is worth knowing as far as graphing stuff? Okay, here's the deal, and I want a yes, but I don't want you to say yes just because you're in agreement with me. Are you going to just graph on your calculator and then blindly copy the graph anymore? No. Okay, real talk, and nobody's in trouble. Did anybody catch themselves doing that last year?
Yeah.
Okay, but you're not going to in here.
Yeah.
Deal. I don't care what your calculator can do. Cool. All right, we have one really important theorem that we're going to gloss over, and it's going to make sense, and it's super easy and obvious once we see it. Last little thing that we're going to write today. Intermediate, and it's actually but I just forgot that. The intermediate value theorem. You will never see me write this again. The intermediate value theorem. You guys ever heard diamonds are forever?
Yes.
That's BS. Diamonds will eventually disappear. Like, they wear down eventually. You know what is forever? Theorems. Theorems really are forever. They have always been and always will be, whether there's people there or not, is my philosophical belief. The intermediate value theorem is one of them that you will see over and over again if you take any more math classes. Suggestions on the shorthand that every mathematician ever uses. The IVT. All right. Now, we're going to look at this in a very specific context right now because we're obviously talking about graphing functions and some zeros and stuff like that. But I'm going to draw the picture. You're going to sketch it as well. We don't even have to be crazy. I'm going to draw a small graph. And I'm just going to work in quadrants 1 and 4 so I can see positive and negative. Okay. Let's say we have some function. And I'm just going to draw some nice smooth curve. I don't care what it does. Let's say on this section it does something like this. Don't care what else happens. I'm going to call this f of x. Don't even care if this function, what it is. Do you agree that it's probably a polynomial function that has a curve that fits through these points roughly? Or even exactly, because there will be, because we could always just make it. Okay. I'm going to pick an interval, some range of x values that we're going to look at, and I'm going to make it a closed interval, and all that means is it's parentheses or it's included. I'm going from x equals whatever to whatever, but I'm not even going to give us numbers. I'm going to say I want this interval to happen from A to B. There is a range of numbers right here. If I only look at A to B, it means I'm only looking at what the graph does inside of this box. You don't have to put the box. This is just I want to really focus. Only these x values right here is all I'm asking about. Now, there is no scale to this picture. We're assuming that f is a polynomial function because we're talking about polynomials. If I wanted to know this ordered pair, can somebody help me? It's a something. It's not a b. I mean, it could be, but b is a positive number. I don't think that's b. Karina claims a comma f of a. Is that true?
Yes.
Okay. Which means this ordered pair up here, very similarly, could be b and f of b. All I'm doing is, because we don't know the y value or the x value, we're just saying, hey, whatever I plug in is what I get, f of that number. Conceptually, everybody cool here?
Yes.
All right, here's everything that we need for the intermediate value theorem. Again, we're only looking at one little tiny case. So here we go. Given a polynomial function, and I'm just going to call it a polyfunc, which, notice, without being crazy wordy, I'm just telling you here's a function that is continuous and it's a smooth curve. Okay, so give me a polyfunction, and in our case it's f of x, such that on the interval from a to b, which there's our closed interval from a to b, on this interval we see every value between f of a and f of b is used. is I'm going to say attained. And I don't know if either of them really makes more sense, but I'm going to pause until you guys catch up because I want to make sure we all understand what this is saying.
How's Minecraft going?
I can't stop thinking about it. Every spare minute of my time that's not focused on something, I'm envisioning my world. And yes, it's true. I do, at this point, have some ancient ruins and am about to make a netherite ingot.
Yay.
Cool. Don't have a way to make armor yet because I've never found an upgrade, but I'm going to find me a fortress. All right. Terribly, actually, turns out, is the answer because I can't stop thinking about it. What? Yeah, it's fine. All right. So, first of all, what is this saying? When I say every value between f of a and f of b is attained, that's the part that I really worry about.
Between those x values that you have, you can get the y value.
So, if we put numbers, it'll make it much more clear, and I don't want you to put numbers on yours, okay? Don't put your numbers. If this is a -2, and this is a +10, is there a point in here between a and b, some x value in this range, where my function has a value of 5?
Yeah.
Like here, it looks like, whatever that is, right? Can you guarantee that there's somewhere in between a and b where if I plug in some c value, my function has a value of, I don't know, -1?
Yeah.
Because it's continuous, I can't go from -2 to 10 without crossing -1, 0, 1, 2, every number in between. Is everybody cool with that idea? So check it out. You all fundamentally understand the intermediate value theorem. Given a polynomial function such that a is on a to b, every value between f of a and f of b is attained. More so, the important part of this, and just to put into our own words, because that doesn't really look like a theorem, we, more than just saying, I think we hit it, we guarantee, and that is a solid guarantee, that every y value between those gets hit. Every y value from f of a to f of b is used. Now, in this particular situation, I'm looking at a very particular part of this. And we're focusing on just that negative to positive part because one of the only two things that we really need to graph a function, and behavior is one of them. What's the other one? The zeros. Do you guys agree sometimes it can be hard to factor? Like, it can be really challenging to factor. Is it normally easier to plug in f of 2, maybe, than it would be to factor it? If I give you some really ugly function, I say find me f of 2, or factor the whole function. Which one's typically easier? You think so?
F of 2, did you just plug it in? No, plug it in.
So I think plugging it in, but I just want to demonstrate. I want you guys to do something for me, and we'll even pick a better number.
Okay, never mind. Yeah, no, plugging it in.
Okay, you can either factor or find me f of 0. Which one do you want to do?
0.
You want to factor it, Red. Is that what you said? I thought you were giving me the wrong answer on purpose. Can we agree that factoring looks like it's going to suck?
Yes.
Okay, what if I want to find f of 0? Is it as bad? What's f of 0? Negative 101. 0 to the 5th is 0 minus plus 0 minus, yeah, it's negative 101. That's easy. Okay, if we do this, and it happens that maybe on this thing, we just found that f of 0 is 101. Do we want to do, yeah, f of 1, for example. 137 plus 2 is 139. Minus 101, 38? That was a negative 101, right?
Yeah.
Okay, check it out. I don't know how to factor this. And we could, and I don't want to spend the time on it realistically. Can you guarantee me anywhere that there is a 0 on this function?
No.
Pause. Is this a polynomial?
Yes.
Notice that I was negative here. At 1, I was positive. If I, without ever picking up my pencil, went from negative 101 all the way down here, and I wound up at 38, what must I have crossed? There, guarantee. I guarantee there's a 0 between x equals 0 and 1. Now, I don't know exactly where it is, but I know it's there. If I wanted to go closer, and I don't want us to actually evaluate this, maybe we do it with technology. Could I figure out f of 0.5? If it was still negative, instead of saying my root is between 0 and 1, we could now say it's between 0.5 and 1. And we could zoom in on both sides, and even if we don't know how to factor it or can't factor it, we can still find our root so long as we understand the intermediate value theorem. Now, it's most valuable in my mind when we use it to find a 0, but it doesn't have to be. If I look at this one and said that, don't add anything to yours, but let's say a was right here. Let's say that that was at 5 and this is at 7. And I said, is there somewhere you guarantee this function has a value of 6 between a and b? If it went from 5 to 7, did it have to cross 6? Yes. It is guaranteed. There's a value there. With 0 makes more sense to use, but it really doesn't matter what we use. Reasonable? All right. So I'm going to give you your assignment, and I'm cool with it. Okay, if I'm not here tomorrow, I will have a video recorded in Anchorage tonight. I'm going to try to record with the microphone on my earbuds, so we'll see how that works out. I also might start wearing my earbuds to use as my microphone so that when I walk around, you guys can still hear it on the video. We'll see. I really want a lapel mic, but they're expensive. Can you guys tell I'm in a terrible mood?
No.
Is he telling the truth?
I don't know.
Good. All right. I'm actually in a really good mood. I'm always in a really good mood because you know what? I love my job. Okay. 2.2.2. We just did IVT and sketching. You guys get homework 2.2 and I'll zoom way in, which you will find waiting lovingly for you. This says 2.2.1. Do we have more 2.2? Nope. Homework 2.2. Weird. You will find on page 133. You get 1 through 7, 11, 12, 17, and 19. And I can't imagine why I did this, but I'm going to roll with it. 75 and 81. Sketches. Sketch, sketch, sketch. Do not plot 50 points. I won't look at 50 points if you plot 50 points. Sketch them. Cool, 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 cool.